Hello, my name's Chris Greenaway, and I'm going to talk to you about the authentication, authorization, and audit functionality available in Terracotta DB. These are the topics I'm going to cover in this video. If you want to jump ahead to a specific one, feel free. Secure connections work using a security root directory. This contains various files that are used for security configuration. You should select appropriate file system permissions so that only processes that are allowed to read those files have access to the directory. On the client side, this directory will contain things such as certificates or passwords. On the server side, you will find that this contains things like certificates or passwords, but also information about how to configure access control. On the server, the location of the security root directory is specified in the tcconfig.xml file. Under the security tag, there's a security root directory tag, and the path for the security root directory can be specified in there. The contents of the security root directory on the server must match the other pieces of configuration that are specified inside the security tag. On the client side, the security root directory is passed in via an API if you're using something like tcstore or ehcache, or via a command line argument if you're using a command line tool such as cluster tool or voter. And the contents of the security root directory are validated as being self-consistent and then used to determine exactly what kind of security configuration is being used to connect to the remote servers. So what we're doing when we configure authentication for a cluster is restricting access to the cluster so that only clients that have valid credentials can make a connection to the server. So there are different processes that will need to make secure connections to the cluster. These include clients like tcstore or ehcache. Other servers in the cluster each server needs to connect to the other servers to share data, for example. Cluster tool and voter, those command line tools, need to be able to connect to the cluster, and also TMS if you're using management and monitoring. Now each of these needs an individual identity and a security root directory. So by identity we're talking about a username and password pair or a certificate, something like that. Now there are three different authentication schemes that you can use when you're configuring authentication for a cluster. You could use one based on certificates, but there's also one that uses files, and another one that allows you to configure LDAP. With certificates, the client passes an identity certificate to the server, and the server checks that that certificate is one that it can trust. With file-based authentication, the client presents a username and password pair, and the server validates the password against a password hash stored in a file on the file system. With LDAP-based authentication, the client again presents a username and password pair, but the server validates that the username and password pair using an LDAP server. Certificate authentication uses two-way SSL/TLS, and the two-way nature allows the server to verify the client identity. The client presents an identity certificate to the server, and this certificate must be signed by a certificate that the server trusts. On the server side, we can configure certificate authentication by putting an entry in the security tag inside tcconfig.xml, looking something like this. You can see we've specified the authentication scheme is certificate. If you use a certificate scheme like this, you also must specify SSL/TLS tag to explicitly turn on SSL/TLS, and also the security root directory to point to the directory where the certificates that the server requires are stored. So you put the certificates that are needed in that security root directory. The root certificate goes in the trusted authority directory, and the identity certificate for the server goes under the identity directory. On the client side, again, the certificates are stored in the security root directory, and we specify the security root directory in the API or the command line for that particular client. Now, if the client needs something like a username and password pair, for example with file-based or LDAP-based authentication schemes, we would put that pair into a credentials.properties file in the security root directory, and it would go underneath the identity subdirectory. So for example, that file might look something like this. The username here is Dave, and Dave's password is secret password. Now for each of your users, so that might be different processes that are connecting to the cluster, you need to specify the particular username and password for that connection. Now if we're configuring file-based authentication, we create a file on the server with a list of users and their password hashes. On each client we have a matching username and password pair, and when the client sends the username and password pair to the server hashes that password and checks it against the file. So to configure file-based authentication on the server, again, under the security tag in tcconfig.xml, we would explicitly configure file-based authentication using the file tag. If you specify this, you must also supply a security root directory inside that security tag. And then under the security root directory, under the access control subdirectory, you would put a users.xml file to specify the list of users and password hashes. And that might look something like this. Here you can see that we've got two different users, Dave and Bill. And you can see that we've used a bcrypt algorithm to generate our password hashes. You can see that that password hash in there starts with that $2A, $10, and then quite a long sequence of other characters that specify the hash. Now to create these password hashes, Terracotta DB ships with a bcrypt tool. You can create a password hash using the bcrypt.sh script on Unix or bcrypt.bat on Windows. These scripts are held under the tool security bin directory, and for example, you could run a command like this, which would create the hash of the secret password. Here we've used -n12, which specifies the number of rounds. It's like a security factor. The larger the number, the longer it takes to generate and check the hash, but the higher the level of security. Now the number that you should choose is dependent on the hardware and the platform that you're using. You should experiment using different values. You may find something in the range of 10 to 13, perhaps 14 works well for you. Every time you add 1 to that, it doubles the length of time it takes to generate the hash. You want a value that maybe generates a hash in the something like 250 millisecond range, although it's a choice about the security factor that you want versus the performance of making secure connections. The password can also be read from standard in. If you just leave the password off, you'll get prompted for that, in case you don't want to type your password into a command and have it appear in your command history. And finally, when the hash is created, a salt is used, giving us meeting a certain standard for storing passwords. So for configuring LDAP, we configure the server with details of the location of the LDAP server and how to connect to it and use it. The client again presents a username and password pair. And when the server receives the username and password, it sends that information off to the LDAP server to check those credentials. To configure a server in the cluster for LDAP, again in the security tag inside tcconfig.xml, we're going to specify inside the authentication tag that the scheme is LDAP. But now inside the access control subdirectory in the security root directory, we're going to put an LDAP.properties file. So an LDAP.properties file might look something like this. And here you can see that we've specified the location of the LDAP server and to some degree the structure and layout of the schema on the LDAP server. The supported list of properties that we support for configuring LDAP matches the Software AG standard LDAP integration, and the full list of properties can be seen in the Terracotta DB documentation. Let's look at configuring authentication and authorization for the TMS now. There are two parts to this. First of all, for the connection between the browser and the TMS. And here we can configure both authentication and authorization. And the second part is configuring the connection between the TMS and the cluster. Now, because the cluster supports authentication, we can do that. And it's configured like any other client. The TMS just acts as another client for the cluster. There are some actions within the TMS that require the user to be authorized, and in this case that's done via giving them the admin role. So those actions are creating or deleting a connection, clearing a cache, reading or writing data to the cache, clearing event log or terminating a server. So let's look at configuring that browser to TMS connection. Authentication and authorization are configured using two properties: TMS Security Authentication Scheme and TMS Security Authorization Scheme. You put these inside the tmc.properties file. If you specify one, you have to specify the other one as well. And you also have to specify the security root directory so that it knows where to find the corresponding files for the security configuration. When the user connects to the TMS, they're presented with a login form and they have to fill in a username and password that then is sent to the TMS for authentication. There are two different authentication schemes that can be configured in TMS: File and LDAP. Note that there's no certificate because the login is done via a login form that takes a username and password. TMS expects to find a user's XML if you've configured File, or an LDAP.properties file if you've configured LDAP, again under the access control directory in the security root directory. For the authorization schemes, there are three different valid authorization schemes: Authenticated, File, and LDAP. For Authenticated, all users are treated as admin. For File, there's information in the users.xml file as to which roles the user is in, and they need to be in the admin role. And again, for LDAP, those roles are configured in an LDAP server, perhaps via LDAP groups. So let's see an example of the user's XML file that includes that role information. Here we've just got one user, Dave, and you can see that underneath the password section there's a roles section, and in this case he's specified as having the admin role. Similarly, the LDAP.properties file becomes more complex as you add in information about roles. So you can see here that the second half of this configuration provides more information about the LDAP schema in terms of determining which groups that user is in. And again, this is all in line with the standard Software AG list of LDAP properties, and the details of all those different properties are defined in the Terracotta DB documentation. There is an extra property that Terracotta DB defines over and above the standard list of properties that Software AG's LDAP integration would normally provide. And this is because the group name inside LDAP might not be admin. So for example, users might have been given by the organization, might have been given TC admin for Terracotta admin. Well, we need them to have the admin role. So we need to have some mapping that says the TC admin group should be treated as the admin role. So there's this additional property, tcdb.rolemap, that allows you to configure a mapping between an LDAP group name and that admin role. It's possible to mix different schemes. So you can have one scheme for authentication whilst there's a different scheme being used for authorization. So for example, you might want to use LDAP authentication but a file authorization. So this might come in handy if your LDAP server knows which users are valid users and can verify their password, but it doesn't have role information, and you could then define that role information in a users.xml file. Finally, on TMS, to configure cluster security, so the connection between the TMS and the cluster, use a security root directory specific for that purpose, and that's configured using tms.securityrootdirectory.connection default, and you set that to the path for that security root directory. The final topic for this video is audit, which is supported by both cluster and TMS. This functionality records security relevant events in an audit log. The kind of events that are auditable include authentication, so whether that's authentication has succeeded or failed, IP whitelist changes, cluster tool operations, and TMS operations that require the admin role. To configure audit in the cluster, under the security tag in tcconfig.xml, you need to specify the audit directory tag with a path to the audit directory. Similarly, on the TMS, there's a property in the tmc.properties file, which is tms.security.audit directory, that should be set to a path to the audit directory. Now, the audit directory itself should be created with appropriate permissions so that only the processes that will write to it have write permission, and only people who should be able to read audit logs have read permission. Inside the audit directory, there's a structure. At the top level, there's a breakout between audit logs from the cluster, different servers in the cluster, and audit logs from the TMS. Under that, there's a breakout by server name and port. Under that, there's a breakout by date, and within inside a single date, there's log rolling. So if your audit log becomes too large, we will start a new file containing the next section of the audit log. That brings us to the end of this video on authentication, authorization, and audit. I hope you found this video useful. Thank you for your time.